Here is the answer for the Day 2 bell work. Draw the condensed structural formula for 2-methylbutane. A structural formula is a drawing where you use C's and H's to mean carbon and hydrogen atoms. You draw dashes to show the single covalent bonds. The word condensed means that you're not going to do all of the dashes to all of the hydrogens. Let's focus in on this name. It has a few parts to it. The end of the name, butane, tells us the parent chain. The parent chain has 4 carbons in it and all single bonds. This part of the name tells us there's a methyl group attached at the second carbon of the parent chain. Now, this asks us to do a condensed formula, but sometimes it's easier to start with a complete formula and change it into a condensed until you've done a lot of practice and you're really good at kind of picturing it in your mind. So here I'm going to make a complete structural drawing, and then I'll just redraw it and make it be a condensed drawing. Okay, start with the parent. Butane has 4 carbons. So you draw 4 carbons connected with single dashes. Then, attached at the second carbon is a methyl group. Methyl has 1 carbon in it. Now I can draw up or I can draw down. There's a little more space down, so I'm going to do that. The last thing to do is to complete this by putting in every hydrogen that is possible to fit. Now all carbons need to have 4 bonds attached. So the carbon on the left has enough space to have 3 hydrogens coming out of it. This second carbon has space above for 1 hydrogen. I can have a hydrogen here and a hydrogen underneath. The carbon on the end can have 3 hydrogens. And now let's look at my carbon that is attached on my methyl group. That carbon needs to have 4 bonds, so it has room for 3 hydrogens. That's the complete drawing, drawing every single carbon, every single hydrogen, and all of the dashes. Now let's redraw this, but make it condensed. An observation we can make is that any carbon on the end of a chain has 3 H's attached to it. So let's start with the first carbon, this one right here. The condensed version of that is to write CH3, a carbon with 3 hydrogens. Then draw a dash. Now let's move to the second carbon in the parent. That carbon has 1 H to it. So the condensed version is to write CH. Now let's connect to the third carbon. That carbon has 2 H's attached to it. So the condensed version is CH2. And now the fourth carbon in the parent, that has 3 H's. So CH3. Now I'm missing the branch. So coming down out of the second carbon, there is a CH3. This drawing here in red is the condensed version. And sometimes with a condensed version, you don't even take the time to draw the dashes. This dash here, this dash here, this dash here are really unnecessary. But you would need to show the dash to show how the branch connects on. Now, question C, write the name of this alkane. To name an alkane, you need to know the parent chain. What is the longest chain? And notice that that just goes straight across in this drawing. A parent chain can twist around, but in this drawing, it just goes straight across. The next thing you do is you number the carbons in the parent. And you want to start from the end that will reach a branch in the shortest way. So you will notice that the carbons in the parent have been numbered with little red numbers starting from the left. And the reason for doing that is because in 1, 2, 3 carbons, there is a branch attached. If we had started from the other end, it's not until 1, 2, 3, the fourth carbon that there would be a branch attached. So we make the decision, we're going to count carbons from the left end. This is the fourth carbon, this one here is the fifth carbon, the sixth, the seventh, and the eighth carbon. An alkane with 8 carbons is called octane. The name of the parent is octane. Now we're going to name the branches, also called substituents. A branch with one carbon is called methyl. This branch is attached to the third carbon in the parent. It is 3-methyl, where the 3 indicates which carbon it is attached to. Now attached to the 5th carbon in the parent is this branch. This branch has 2 carbons in it. Its name is ethyl. And because it's attached at the 5th carbon in the parent, it is called 5-ethyl. Notice the use of the dashes separating the number from the letter. To make the name, we write the branches first and then end the name with the word octane. Branches are listed in alphabetical order. E comes before M, so ethyl is going to be written before methyl. Here we go. This is the final name. 5-ethyl dash 3-methyl octane. You'll notice that every time there is a number and a letter side by side, there is a dash which separates them. Further, notice that there is no space separating the branches from the parent name. The name is 5-ethyl 3-methyl octane. This tells us there's an ethyl group attached at the 5th carbon, there's a methyl group attached at the 3rd carbon, and that there are 8 carbons in a parent chain.